Welcome to the Low Carb MD podcast. No one is beyond help. No one is beyond hope.
As we have always said, we are bringing you medical information and cutting-edge science, but none of this is medical advice. Please seek out input from your own doctor.
Guys, and welcome to the Low Carb MD podcast. This is going to be a great one. And again, I have the awesome honor to be a co-host with Dr. Kristen Baer. Dr. Brian Lenskis is, I think, getting a screening colonoscopy, or maybe he's watching Matlock. Who knows what he's doing? Maybe I think he's like at the early bird special right now at the diner. Sorry, Brian, we love you. I'm just kidding. But I'm making fun of his age, guys. I'm here with Dr. Kristen Baer, and we have a really special guest, somebody a lot of you probably already know. Kristen, you want to do the introduction?
Yeah, hi everyone. Today I'm so excited we get to interview Dr. Tommy Wood. Dr. Wood is a research assistant professor of pediatrics in the University of Washington Division of Neonatology. The majority of his academic work has focused on developing therapies for brain injury in newborn infants, but also includes adult neurodegenerative and metabolic diseases, as well as nutritional approaches to sports performance. Tommy received an undergraduate degree in biochemistry from the University of Cambridge, a medical degree from the University of Oxford, and if that wasn't enough, a PhD in physiology and neuroscience from University of Oslo. Alongside with his academic training, Tommy's coached athletes in dozens of sports, from weekend warriors to Olympians and world champions. He is the outgoing president of the Physicians for Ancestral Health Society, a director of the British Society of Lifestyle Medicine, and sits on the scientific advisory board of HINSA Performance, which includes researching performance optimization strategies for F1 drivers. Its current work includes physiological and metabolic responses to brain injury and their long-term effects on brain health, as well as developing easily accessible methods with which to track human health, performance, and longevity. So quite an accomplished guy we have here. Dr. Wood, thank you so much for joining us.
Thanks so much for having me. It's a pleasure to be here.
So I love Ragnar. Can I just say that, Doctor? Is that your middle name, or is that?
It's my middle name. It's my grandfather's name. I
love the Vikings show, and then Ragnar is a kind of connotation. So I love it.
So there's so much we want to talk to you about today, and I want to just dive right into it here. Kind of the hot topic in the low carb and ketogenic world is insulin resistance. Mm-hmm. And even the name insulin resistance is gaining some controversy. Is it hyperinsulinemia? Should we be calling it metabolic dysfunction? But what is kind of the topic of debate is the root cause of insulin resistance. And there are a few theories out there. Is it from too much carbohydrate consumption, or could it possibly be from these polyunsaturated fatty acids? A big debate right now. Tommy, what are your thoughts on the root cause of insulin resistance?
Yeah, I have many thoughts. And I think the best place to start is maybe to take a step back and think about how we're measuring insulin resistance. Or maybe before that, we talk about what insulin does. I think that's something that's generally misunderstood, pretty much no matter where you are in terms of carbohydrate camp. So the main job of insulin is to control circulating energy, basically. And most people think about insulin being there to shove glucose into cells, right? Insulin shows up, you open up the gates and glucose goes into cells. But actually, that's not really true at all. And that does happen at very high doses of insulin, but that isn't what is happening in a normal, so like a person eats a regular meal that includes some carbohydrate. The amount of insulin that is released is not enough to increase glucose uptake into cells. So I think the best way to think about it is to think about where insulin is released and then where it goes around the body and then the jobs that it does as it goes. So the first thing insulin does when it's released in the pancreas is it goes to the cells next door and it stops the release of glucagon, which is like the antagonist of insulin, right? Together they decrease and increase glucose. Then it goes to the liver, and the combination of higher insulin and lower glucagon means that you make less glucose in the liver, gluconeogenesis, right? So you shut down gluconeogenesis. Then it goes around the body, and the first thing that it does is it stops the breakdown of tissue, particularly muscle tissue. So decreases what we call proteolysis, or the breakdown of protein, and decreases lipolysis in the fat tissue, which is sort of the breakdown of fat. And those things together are what regulates glucose production, or the glucose level in your blood, much less than increasing glucose uptake into cells, because most of the glucose that is floating around in our bloodstream, particularly if we're type 2 diabetic or we're insulin resistant, most of that glucose is being made by the liver. It's not come from the diet. And the muscle tissue breaks down, fat tissue breaks down. That creates amino acids and glycerol. They go to the liver and they get turned into glucose. So when you're insulin resistant, those tissues are breaking down when they shouldn't be, because insulin is not there to stop them breaking down, or the signal isn't there to stop them breaking down, and your liver makes more glucose than it needs to. So that's kind of what insulin does. At much higher levels, it can then increase the flux of glucose through the cell to be used for energy. And then at even higher levels, it can increase the uptake of glucose into cells. But most glucose uptake into cells is actually driven by the amount of glucose rather than the amount of insulin. And so then when we look at insulin resistance, the way we test that, sort of the gold standard test, is something called a hyperinsulinemic euglycemic clamp, which basically means that I put catheters into your veins and I stuff you full of insulin and glucose at much higher levels than you would normally be exposed to. And I see how much extra glucose I can shove into your cells with really high levels of insulin. And already you're asking insulin to do something which it doesn't normally do, right? So this is already completely supraphysiological, we'd call it. And so when you look at somebody who is type 2 diabetic, we'll take that as like the sort of the peak of insulin resistance, essentially. They already have more glucose going into their cells because there's more of it floating around, and the cells are taking up as much as they can. So when you then ask those cells to take up even more, then they will respond less, because they're already basically at max capacity. And so that is what we term insulin resistance, that you get less glucose uptake into cells when you shove a whole boatload of insulin into the system. And so I think this then brings us on to what causes insulin resistance. And the main thing in most people is energy toxicity. It's just too much energy in your cells, more than they want. And particularly in the fat cells in your adipose tissue, but it could also be muscle tissue as well, potentially. And this is modulated by multiple things. So it's actually, in my mind, an interaction between how much energy is in the cells and how much energy those cells can process, which is modulated by oxidative stress or reactive oxygen species and inflammation. And then the type of energy, like whether that's carbohydrates or fat, also plays in. So people may have heard of something called the personal fat threshold, which is basically how much fat can your body store. And in general, your fat tissue is a metabolic buffer. It's super important because it's there to take up the excess energy that you don't want floating around, causing damage in various ways that it does. However, and then the amount that you can store is very dependent on, say, genetics. So white people can get much fatter than most other ethnic backgrounds. That's just a genetic thing. But it's also modulated by things like inflammation. So if you have a chronic inflammatory disease, it could be an autoimmune disease, or some gut health issues that mean that you have this sort of big systemic inflammatory response. Then your fat cells actually can get less big. So you'll reach your threshold earlier, and that's the point when the fat tissue is breaking down when it shouldn't be. The glycerol is going to the liver is making glucose when it shouldn't. So that's, in my mind, that's basically the root cause of insulin resistance, is this combination of energy toxicity, or that's the main signal, but that can also be the amount of energy that results in toxicity will be modulated by things like overall inflammation and oxidative stress sort of within the cell.
That is a great explanation. So energy toxicity appears to be the root cause of insulin resistance and leading the way for type 2 diabetes. Where do you see the polyunsaturated fatty acids fitting into this paradigm here? Is it the inflammation that they cause at the level of mitochondria, or what's your take on that?
Yeah, it's a really good question, and it's actually much more complicated than most people. Just like I made insulin resistance much more complicated than other people did, I'm going to make PUFAs or polyunsaturated fatty acids much more complicated. In the acute setting, so if I gave you like a big glass of canola oil and compared it to, say, butter, the same amount, when you process the PUFAs, so linoleic acid is going to be the major omega-6 that's in that canola oil. When that's processed, that actually changes the amount of reactive oxygen species that are produced in the mitochondria, and relative to saturated fat, you'll be more insulin sensitive because of those PUFAs. So they've done nice studies where they put people on a ketogenic diet, so very high fat, it was only 5 days, but they compared saturated fats versus PUFAs. And those who were on the PUFA ketogenic diet were more insulin sensitive, they had higher levels of ketones, and they had lower levels of glucose. So in the acute setting, PUFAs make you more insulin sensitive because of the way that they're processed. And there are multiple randomized control trials that show this. If you swap saturated fat for PUFAs, then you will see relative to saturated fat, you'll see an improvement in insulin sensitivity. Now, immediately people will be like, wait a second, that doesn't sound right, because like PUFAs are supposed to be bad, right? So yes, the story continues, unless you had a question, because I see you're ready to ask a question.
No, you're right. There's so much I want to ask you, but this is where the term insulin resistance can be confusing, because you are saying that PUFAs can make cells more insulin sensitive, but I think at the level of the fat cells, that's where it gets confusing. If your fat cells or your adipose tissue is insulin sensitive, they're going to keep growing. I don't know if that's the direction you were going to take it, but I wanted to clarify that and get some thoughts on that as well.
Yeah, so that is definitely partly where I'm taking it. So animal studies, and if you believe nutritional epidemiology in humans, which most of us shouldn't, because most of it is pretty rubbish, where you just ask people what they eat and then look at their disease state 10 years later. I mean, the data is terrible, but it does seem that if you have a higher proportion of your calories from PUFAs, so it's particularly going to be linoleic acid in soybean canola oil, then you can gain more weight. And in animal studies, for the same number of calories, if there are more PUFAs in the diet, those animals gain more fat. And it is exactly because their fat cells are more insulin sensitive. And therefore, they accumulate more adipose tissue. So in the short term, yes, you'll be more insulin sensitive. That means you can gain more weight, which again, and that those fat cells, the ability to gain fat is a metabolic buffer. But eventually, you will still get to a point where you have energy toxicity, but you'll maybe a bit fatter at the point where that happens. So we can discuss whether that's a good thing or not. And that seems to be a downstream effect of what happens when PUFAs are metabolized in the cell. The other side of it, which I think is very important, or there's two other sides that are very important. So one, in the developing brain, which is obviously where I spend a lot of my time researching, if you have a very high intake of linoleic acid, and so this is like the specific omega-6 PUFA, which comes from these refined vegetable oils, it inhibits or competes with DHA for uptake into the brain. DHA being the long chain omega-3 that you get from fatty fish and things like that, which is one of the most, if not the most important fat in the brain, particularly in the developing brain. So if linoleic acid is high in the diet, and that we used to have formulas that were basically just made from soybean oil, or it's the linoleic acid content of breast milk has a roughly tripled in the last 3 years, and it comes from about a third of the diet of the mother, and that is, you know, linoleic acid intake has increased significantly over that same time period, and then the other 2/3 come from stored body fat. And again, the fat on your body is mainly the fat that you ate at some point. So it's increasing in breast milk, it's been increasing in formula, and then it will then result potentially in less DHA in the brain, which is one of the, like I said, one of the most important fats in the brain. So that concerns me. And I think also in the setting of a brain injury, DHA is super important, and particularly because of the downstream signaling molecules that are generated from DHA and EPA, which is, you know, the other long chain omega-3. And so if we think about an acute injury or an acute inflammatory reaction, which is the final piece of this puzzle, which I think is really important. When you first get some kind of inflammatory reaction, you create these signaling molecules, things like leukotrienes, and they are made largely from arachidonic acid, which is an omega-6. And so when people talk about omega-6s being pro-inflammatory, that's not necessarily a bad thing. So arachidonic acid is a long chain omega-6. It mainly comes from animal foods, but you know, people with it depends on genetics, but people can make it from linoleic acid. And so that creates the initial inflammatory molecules. So those are important because you need to create an inflammatory reaction. That's part of healing. However, after that first reaction, you then want to resolve the inflammation, and you create something called specialized pro-resolving mediators, or SPMs, which come in multiple different classes, but they're mainly made from those long chain omega-3s, DHA and EPA. So you want those to be present. You need enough of those so you can resolve an inflammatory reaction. But if you have high levels of linoleic acid, so this is, again, come from the diet, maybe it's reduced the uptake of the important omega-3s into the brain, or maybe not. It might just be there in high levels because you've consumed a lot of it. Those compete for the same enzymes that would produce the SPMs from the omega-3s. And you end up with things called oxidized linoleic acid metabolites, or OXLAMs. And these things can cause chronic inflammation, as well as stopping you creating those beneficial resolving mediators. So in the setting of injuries, continuous inflammation, then having this particular omega-6 PUFA, linoleic acid, can sort of prevent the resolution and maybe increase long-term inflammation. So to kind of tie it all together, in the short term, yes, omega-6 PUFAs might make you more insulin sensitive, but this appears to result in greater weight gain. And then in the setting of which most of us live, you know, we're constantly bombarded with things that cause an inflammatory reaction, or we get injured. And then in that setting, it's going to essentially result in worse inflammation long term. So it very much depends on when you're looking, why you're looking, and, you know, what else is happening in the body. But people sort of conflate this short-term benefit in terms of insulin sensitivity compared to, say, saturated fats, versus the sort of the much bigger and more important picture in my mind, which is what's it doing to the fats in the brain, what's it doing in the setting of chronic inflammation, which again is incredibly common. So like I said, I made it much more complicated, but hopefully that sort of helps people figure out those different strands that they'll hear, because they'll see a meta-analysis. You know, somebody will say, here's a meta-analysis of randomized controlled trials where they gave people PUFAs, right? They swapped saturated animal fats for, you know, safflower oil or sunflower oil or canola oil, and look, they got more insulin sensitive. And then all of a sudden, like, you don't know what to believe. So that's kind of why those different streams of thought happen.
I'm going to ask a question. So guys, just for the listener, we're talking about oils that are high in omega-6, fatty acids. We're talking about safflower, rapeseed, canola, sunflower. What am I missing? Which
soybean.
Soybean. Oh, soybean's the biggest one. Okay. Yeah. So we're talking about these oils because the conventional medical and scientific approach is to replace your diet with these. That's what they recommend. Whereas if you talk to most ancestral-based keto, carnivore, low-carb practitioners, they'll say you probably want to avoid these oils for the reasons Dr. Ragnar is mentioning. I'm going to play a little devil's advocate. This is something I do all the time, okay? So I'm going to give you kind of the if we had a typical cardiologist or lipidologist here, what they would say. They would say, look, okay, look at nuts, look at seeds, they're associated with better outcomes, okay? And if you look at the association data, look at PUFA intakes on food frequency questionnaires, they're associated with better outcomes. Look at serum PUFA, and it's associated with improved cardiovascular mortality. So actually measuring the PUFA in the blood, there's been studies showing that improves cardiovascular mortality, and I think it's also been shown to decrease mortality. So here is like a body of evidence, a large body of evidence, and maybe we'll skip, I think our listeners pretty much understand the weaknesses of the health user bias on the, for the epidemiologic stuff. But I mean, they're measuring, I know where this may go, and I'm just curious to hear your thoughts. They're actually measuring serum PUFA, and that's associated with cardiovascular mortality. So help me, why should I believe, I believe you, I practice this, I have almost no seed oil in my diet, and maybe we can tease apart some of the nuance there, but why should I believe you?
Yeah, that's a great question. First, maybe we'll go in reverse order. The first being that circulating fatty acids are not directly related to the fatty acids in the diet. So you can swap in and out saturated fatty acids and PUFAs, and then and then you don't see changes in the circulating fatty acids. Same with dietary fatty acids. So you can't equate those. You can't say that eating more or less of this is going to result in more or less of this circulating, because they are signaling metabolites. The type and fatty acids that you have circulating in your body are regulated by the body to have certain effects, say on the insulin sensitivity of a cell. So this is a regulated thing, and your body will determine the saturation of the fats circulating to some degree. So you can't say eat more of this, that means you'll have more circulating, that means you'll have better outcomes. It doesn't work like that. We won't touch nutritional epidemiology because, like you said, most people probably appreciate that that's essentially nonsense. And when you look at maybe we'll briefly touch on it. When you look at food frequency questionnaires, so there are two main types, and maybe two main studies, or three main studies that people will have heard of. There's the health professional follow-up study, which is paired with the nurses health study. These are both run out of the Harvard School of Public Health. And then there's NHANES, which is the National Health and Nutrition Examination Survey. In general, what happens is you ask people what they eat. So the nurses health study and the health professionals follow-up study they give you a list of foods, and they say, on average, how much of this did you eat over the last year? So if anybody just wants to take a stab at how many tablespoons of heavy cream they had over the last year, I guarantee you have no idea. And so that's what they're asking people to do. And then they'll say, oh, well, these people told us what they ate. What's their health status in 20 years' time? NHANES is slightly different. What they do is they say, what did you eat the last 24 hours? How typical is that of what you normally eat? And again, they do the same thing. And when you look at the data, and my favorite thing is always to look at they'll tell you in a particular study, they'll say, here are the people we included, this is what they ate. And if you look at the calorie intakes, in general, like calorie intake, so that's where I start, right? Calorie intake is like 1,500 calories on average in each group. It's like impossible. Like there's no way people are eating that little. And that's what the studies show, basically, that more than 50% of the people in these studies have underreported what they ate, so much so that it would be completely incompatible with life. Like that's how bad the data is. So essentially, like when you see that stuff, you can pretty much ignore it, because we don't know what those missing 1,000 calories are, right? That's super important. Okay, yeah. So that's that bit. Then the last thing is nuts and seeds. Yes, absolutely part of many ancestral or hunter-gatherer diets. And yes, they do contain, seed oils, or they do contain linoleic acid. When you look at ancestral consumption, it's probably about 2% of calories coming from linoleic acid, and it's coming from nuts and seeds and things like that. And that's completely normal, right? But when you look at the average intake in the US, it might be somewhere between 10 and 20% of calories. So you're in a complete, you're basically one order of magnitude, right? 10 times more than you would get from the regular diet. So yeah, if you're like, I don't think you need to completely eliminate linoleic acid from the diet, because it's pretty much impossible. And it's not, something that we, evolutionarily, we do get some of this, but when it becomes, a significant contributor, right, it's making up to a fifth of your calories, and it has all these other effects, then it becomes a problem.
Well, I'm going to keep going down this rabbit hole, okay? Because,
all right.
I look, again, I'm going to put the disclaimer. I probably have less than 2% of my diet is these oils, right? Okay, but so now we have food frequency questionnaires, we have epidemiologic PUFA intake, we have serum PUFA, associating, and I've even seen like fat biopsy data showing a decrease in mortality, with increased linoleic acid. And every part of me is like, I'm not going to eat this stuff. There's no way I'm going to guzzle soybean oil. And especially when you look at the mechanistic data, like you've talked about, the inflammation, and it says like, it just doesn't make sense to me. And, I don't want any oil, really. I don't see any benefit in having much of any type of oil or added fat particularly. But, they've even biopsied fat, and it's associated with improved all-cause mortality. So when it's like, oh man, all the dominoes or all the chips are stacked against that message, so what do you say about these fat, they've done fat biopsies, and if there's more linoleic acid, it's improved all-cause mortality. What do you?
Yeah, so I think you're thinking of this one particular study. They did it it's a Swedish study, I believe, where they looked at linoleic acid content of adipose tissue, and it was associated with a reduction in all-cause mortality. I don't think it was a big effect, and I also believe that the overall intakes required to get those amounts of linoleic acid in the adipose tissue is much less than, say, what we might see in the average American diet. So I think that's potentially part of it.
We're looking at a healthy population.
Yeah, so an overall, and so one potential benefit, right, could be that if it allows your fat cells to keep expanding, you create this metabolic buffer I talked about. So that could be beneficial in its own way. But you have to remember that in general, the Swedish population is much healthier. It's more active. There's many other things in the Swedish lifestyle that are protective. So you're right. That's I'm having to find a caveat in like every single study you bring up. But the final thing potentially is also linoleic acid in the Swedish diet is not highly oxidized, peroxidized. It's not like it's not in your French fry fryer, heated and cooled multiple times, multiple cycles, which basically result, you're creating all these sort of like peroxidized weird, sort of lipid metabolites that end up, having multiple negative effects. So like all of that, if the linoleic acid comes like from something expeller pressed and it's just so in the UK, we sort of like fancy organic rapeseed oil is super in vogue to like make it in a salad dressing or something. If it comes like that, it's probably much less bad than if it's like commercial soybean oil that's been in your McDonald's fat fryer for like a week. Right, those are just two completely different things. So like all of that comes into play as well.
Can you help me understand that? Because I think this is important, because people are like, oh, I'm not going to have any polyunsaturated fat. I'm not going to do it. And then, is there a difference between the polyunsaturated fats in meats and nuts and, that are, versus like, I don't know, let's bring it down, a raw nut versus like a roasted nut in peanut oil, or, help me understand the difference here, because I think and what you said is important, like a cold pressed, oil versus like a highly processed, McDonald's grade soybean oil. Like who knows what chemical reaction is happening in that fryer after a week.
Yeah.
Can you help me understand this?
Yeah, of course. So there's multiple components at play, like you suggest, and people have looked at all the different oils and how they respond to heat. So particularly you heat them up to like frying temperature. So 180 degrees Celsius, 350-ish Fahrenheit. And then you cool them down and you do multiple cycles. And you see that highly refined soybean oil, canola oil, they become peroxidized, right? Which basically means the fats have their own oxidative stress, and you create free radicals and all these things. That happens very quickly, particularly with multiple rounds of heating and cooling, which is what you would see in a typical fast food fryer.
So if I'm microwaving my French fries, you mean like that?
Yeah, well, they've already been fried and then you microwave them again. Yeah. So,
okay.
so that's probably like the worst end of the spectrum. Then there are other things that could be in that fat that could protect against that. So olive oil is an example. Some olive oils do have, olive oil is mainly oleic acid, which is a monounsaturated fatty acid, or MUFA, but some, which can be, because it has one unsaturated bond, it can be susceptible to this peroxidation. But then some olive oils also have a certain amount of linoleic acid in them. But olive oil in general, particularly if it's extra virgin or virgin, has other compounds, so tocopherols particularly, so vitamin E compounds that are antioxidants. So olive oil, you can heat up and cool multiple times, and it doesn't undergo this same peroxidation because it's got these antioxidants that create a buffer. So that's also going to be present in most of the nuts that you eat. It's potentially also going to be present in the fat and meat, because cells have their own antioxidants, and that could potentially be protective. You can reduce some of the potentially negative effects of high heat cooking if you're worried about that by putting some olive oil on it, putting various herbs and other things on it. Marinating meat reduces some of the oxidative sort of like oxidative stress based products after high heating. So it really depends on the context of the food, and that's why I think if you go down the road of just saying, if all of your macronutrients come from whole foods, like not ultra processed, not highly refined, and that's going to be, it could be nuts, it could be the fat and meat, but just avoiding things like oils, and that there's all other, you've talked about refined carbohydrates many times, so we don't just talk about that, but in the oil setting, if that fat is in the context of an actual like food, it's going to be relatively protected compared to these refined oils that then get used separately.
I think it's hard for the average person. I'm sorry, Chris, I'm gonna let you go here. I think it's hard for the average
No
person.
problem.
What's that?
So go ahead.
Yeah, I think it's hard for the average person to make sense of this data. It's like, okay, you have poop, like you just, even as a doctor looking at it, and a scientist, kind of, here we are looking at the primary data, and it's so conflicting, and is it the oil? Is it how we use it? Is it, so I appreciate you going into it. All right, sorry, Kristen, there you go.
No problem, thanks. So I was just gonna kind of make this a little more practical for some of our listeners, because I think one of the most common pitfalls I see in practice with patients starting a low carb or ketogenic diet is all the excess fat that they add to their food. They think ketogenic, I need to eat a lot more fat. They're laser focused on macro ratios, and they're adding these oils and butter and cream to everything. I know you're not a fan of bulletproof coffee, nor am I. I'm really not a fan of adding oils, beyond just a little bit that's needed for cooking sometimes. But I think what you're saying, it's kind of important to realize it isn't necessarily just about the calories, but the inflammatory process and the oxidative stress that some of these oils can cause as well. How do you think this affects the gut microbiome in terms of these processed oils and fats?
Yeah, that's a great question. Just to touch briefly on what you said about all the added fats in a ketogenic diet, I think it's really important to think about the context of why the diet is being used. So if we think about therapeutic ketogenic diets, maybe it's for a certain type of cancer, maybe it's for pediatric epilepsy, where the absolute level of ketones is going to be important in terms of treating the disorder, or reducing the symptom burden of the disorder. Then yes, having a high ratio of fat to protein and carbohydrate calories, so like 4:1 or 3:1 is where most people might start. That's going to be important, and it's also worth mentioning again that if you need ketones to be higher, then having more unsaturated fats in the diet will result in higher ketone levels. And so the original ketogenic diets for pediatric epilepsy, they were basically just chugging back canola oil plus a little bit of protein, which, I mean, sounds terrible, right? But it would result in higher ketone levels. So if you're chasing ketones for a therapeutic reason, then, right, sort of finding ways to get the majority of the calories, or a significant majority of calories, to come from fat can be important. If people are just using this for weight loss, various other general benefits where the absolute levels of ketones don't matter, then I think, you know, adding in all these refined fats has potential negative effects. And, you know, for multiple reasons, I think it's also important that people eat more protein on lower carbohydrate diets, particularly if they have athletic goals. And if they're chasing ketones, then eating more protein is going to reduce their ketones. They'll eat less protein, and there's going to be potential negative effects there. So it really depends on the context of the diet. I think that's important. When you think about throwing back all these highly refined fats, the thing that I think about is something called metabolic endotoxemia, which is just some fancy words to say that there are toxins in what we call the endotoxins that sit in the wall of certain bacteria, gram-negative bacteria, and they seem to be able to cross the gut wall or get into the circulation better with refined liquid fats, particularly. And when you look at the circulating endotoxin, it seems like the more you have, or like as people get more and more symptoms or signs of metabolic syndrome, so HDL cholesterol, blood pressure, higher fasting blood glucose, waist circumference, those guys, as the number of those things increase, the amount of circulating endotoxin seems to increase. And also, when you have a high-fat meal, and the way they test this is they get you to drink heavy cream, and they look at how much the endotoxin increases in your bloodstream. The more insulin resistant you are, the greater the increase in these endotoxins that come across the gut. So if you're somebody who's dealing, and what happens is a lot of these, particularly if you already have a slightly dysbiotic gut, which is very common with, you know, the standard Western or standard American diet. So these things can cross and they can cause an inflammatory reaction. So in the lab, when I'm trying to model brain injury, one of the things that I do is I could inject endotoxin. Essentially, I can inject LPS, which is with a lipopolysaccharide, which is essentially endotoxin, and from E. coli. That's like the standard, typical way in the lab that we create an inflammatory reaction is by just injecting these things. You can do it in humans, you can do it in animals, and see this big inflammatory response. So if you're somebody who has metabolic disease, and which you're trying to reverse with diet, and endotoxins are a part of that, which they could be for some people, then throwing back liquid fat like heavy cream or a bulletproof coffee is essentially just going to throw, you know, gas on that fire. The other side of that is that, so a very good friend of mine, Lucy Mailing, she's an expert in the gut microbiota, and she's written about hydrogen sulfide dominant SIBO or overgrowths in the gut. And the bugs that are associated with this, they essentially love fat. And so, you know, a certain proportion of people who I've worked with who've gone on low carb or ketogenic diets, and particularly if they've, you know, included a lot of these, say bulletproof coffee is like the starting point. But, you know, they're supposed to, you know, you're like, you take bulletproof coffee and you'll just have limitless energy and limitless cognitive performance. But these people feel like brain foggy and they don't feel great, but they're like, but I should be taking this because it's good for me. And it's some interaction with the gut, and it could be this hydrogen sulfide dominant SIBO. It could be they have some element of increased endotoxins being brought across the gut wall. And what they see is that when they take these things out, they feel much better. So it's not everybody. There are going to be plenty of people who will drink bulletproof coffee and their blood tests will look great and they'll feel great. And if that's the case, there's absolutely no reason why you should stop doing that. But I have seen plenty of people who just don't feel as good as they should do, chugging heavy cream and bulletproof coffee on a ketogenic diet. And there's certainly an interaction with the gut microbiota there. In general, though, I don't think we would say that a ketogenic diet is quote unquote bad for the gut microbiota. That's what you'll hear, like, you know, it depends on whether you are going like full carnivore and you haven't really included any, sort of traditional plant fiber in the diet. Many low carb diets do still include lots of plants and they're getting some fiber. So there's kind of like it would depend on which road you've gone down. But in general, people who do things well, they won't get, if you don't have gut symptoms, if you're still pooping well and regularly, I have no reason to be worried about your gut on a ketogenic diet. Like most of the studies are fairly biased, fairly flawed, that would say that, you get a decrease in diversity, or, such and such happens. If you have no gut symptoms and you otherwise feel well, then I think that the concerns about a ketogenic diet and the gut are overblown. But, again, you have to really be guided by the person and their symptoms and how they're responding to various aspects of the diet.
Is there anyone you would not recommend a low carb or ketogenic diet for?
Yeah, I think that again, it really depends, right? So are we talking about a therapeutic ketogenic diet? Are we talking about a low carbohydrate diet, just that it's lower than standard recommendation of 40 to 60% of calories coming from carbohydrates? Because the latter, I think anybody could eat that, they'll do just fine. The human body is incredibly robust, and there's nothing to say that it will just fall apart if fewer than 40% of the calories come from carbohydrates. I just don't believe that's true. I think there is some ancestry that will play into that. So people whose most recent ancestors were in Northern Europe, so that would include me, we probably didn't get very many carbohydrates, particularly in the winter. I mean, if you ever been to Norway in the winter and tried looking for a starchy carbohydrate, literally impossible. So then I think those guys are probably going to, be much, better adapted, maybe we'll say, to lower carbohydrate contents. Whereas people who most recent ancestors, come from somewhere equatorial, right? You're going to have plenty of carbohydrates all year round, and there will be some genetic downstream effects from that. So that maybe plays a little bit into it. But other than that, I think most people can survive on a wide variety of well-formulated, healthy, whole foods-based diets, where sort of fat and carbohydrate sort of go up and down. In terms of, I think that the one area where we have some question marks is like the highest level of elite athletic performance, just because great evidence doesn't really exist. So there's a little bit of some fairly biased trials of low carbohydrate or ketogenic diets in high level athletes, but really it's not very good, and understandably not many elite level, like world championship level athletes are going to say, oh yeah, I'll just try this completely different diet right now and see what happens, right? Because their salary comes from their performance, and they're very unlikely to want to try those things. So we have like various case studies, and I think in general, somebody who's like a fairly general, or just like an amateur athlete. I'm an amateur athlete, Dr. Tro's an amateur athlete. We want to perform well in the gym. We want to look good. We want to feel good. We want to perform well, but it's not paying our salary, right? And for those guys, I think in most sports, if you adapt well enough, reducing your carbohydrate intake probably isn't really going to affect your performance very much. Although I will say, again, I think you should increase your protein intake. And again, that's going to decrease your circulating ketone levels, but that's probably not what you're worried about. You're probably worried about, say, body composition or something like that. So I think for most people, unless you have a very specific need, be that medical or physical, I think in general, most people can eat a low carbohydrate diet just fine. But it really, what that means, what low means, it is also, very different from scenario to scenario. Sorry, maybe that didn't answer your question at all.
What pisses me off? What pisses me off is, we recognize that a majority of America is metabolically sick, overweight, or obese, right? Mm-hmm. More than the majority are. In fact, probably 2/3 are either overweight or obese. So everybody's got to reduce calories. Yeah. Nobody has a problem saying we should reduce calories. Yeah. Right? Everybody should, maybe 10% or less don't have to reduce their calories, right? Yeah. Maybe. Right? But if you say 10% or less have to reduce their 10% or less right? Like besides that, to 90% have to reduce their carbohydrates. If you say that, it's like you're a zealot. If you say calories, it's like, do carbs not have calories? Right? Do carbs not have calories? So how is it that we can say 90% likely will benefit from caloric restriction? Well, don't carbs have calories? Don't processed carbs and sugars have calories? Well,
Yep.
so I think it's an incredible double standard. I can't find anybody, the only scenarios I can see that benefit from carbohydrates are sulfonylurea overdose, insulin overdose, symptomatic, well, I would even argue like acute, severe symptomatic, hypoglycemic shock, okay, and possibly insulinoma. I can't find another, and cachexia, maybe I wouldn't, cachexia, and I guess to some extent the pediatric population, right? Or even, but given the pediatric obesity epidemic, I think we could even argue carbohydrate restriction would benefit them. I can't find many people who would benefit from not reducing carbohydrates. Is that my zealot?
No, I don't think so. So I agree. So the pediatric that is important, right? If we think about low carbohydrate diets in the pediatric setting, I don't think most kids need to go quote unquote low carb. There is some great data from Richard Bernstein's work in type 1 diabetic kids where they go pretty low carb, but again, a big emphasis on protein in that group, and those kids do very well. But in general, I don't think like your kid needs to go low carb. However, so I think that where the problem comes is when people who are very pro low carb say that in order to lose weight, you have to go low carb, and it's because of insulin, and then that's where everybody starts to go crazy. So if you acknowledge that, as long as the goal is achieving sustained reduction in caloric intake, and then for a lot of people it's much easier to do that using a low carb diet, then I think you can find some areas of agreement. And again, I think what's potentially important is, or what I always start with, is the quality of the food, right? So if you have highly refined carbohydrates, they result in completely different physiological responses compared to a potato, right? If you're eating cake versus potato, the amount of insulin that's released, the incretins in the gut, satiety signaling is completely different. So if you're eating very calorie dense refined carbohydrates, you essentially hijack normal satiety and physiological responses to food, and that results in overeating and like all those downstream effects, unless you are somebody who's very good at counting calories, which in my opinion is like one of the most miserable things that you can ever do in your entire life. So as long as you can say that, yes, the important thing is energy toxicity, it's calories, and we prefer low carb approaches because that's sustainable, and you'll increase protein, and you'll probably increase some other important nutrients that are going to come from the foods that you're eating, then great. So I think it's just that people who just say low carb is the only way, which plenty of people do, that's where the argument starts to come in. That's my personal thought.
Well, okay, so I know Kristen, I'm like talking so much here. Kristen's like being so patient here, and I'm like rattling on, off and on. Here's the thing, okay? So I haven't, when you look at the carbohydrate insulin model, and it has its flaws, okay, let's just break it down to like the most clearest level, okay? The only class of drugs that increase insulin that causes weight loss is the GLP-1 agonists. Okay, it's the Saxenda, those probably have effects on an appetite as well. They probably work through causing nausea, but if you look at the area under the curve, they probably decrease total insulin production. So guys, I'm going to make this super simple. If you look at every class of drug, whether you give insulin or cause more insulin to release, it causes weight gain, right? It causes weight gain. Okay, the only class of drug that's ever caused an increase in insulin and decreased weight is a class of medications called Saxenda and Ribellus, and that's the but that also makes you feel full, and it delivers insulin more efficiently. And so the total area under the curve for insulin is probably down. So, I mean, there's something to be said about the truth of, or at least true aspects of the carbohydrate insulin model. And I found it really difficult why people resist, these at least true aspects, whether it's the increased insulin, maybe it's the reactive hypoglycemia, maybe it's the fact that it does something to resting REE or RMR. Maybe it's due to the fact that it decreases blood energy an hour or two after release. I mean, there seems to be something there, but I found that most people resist this idea that, hey, there's something that could be true about the carbohydrate insulin model, and maybe not in its strictest interpretation.
Yes, so in the simplest form, like we went back at the beginning, talked about what insulin does. Insulin does not increase uptake of fat into fat cells. People will say that it's not true. What it does is it stops the breakdown of fat tissue, right? So fatty acids are being taken up into fat tissue all the time. So if you imagine that your fat is a bathtub, right? The tap is always on, pretty much. And then insulin regulates the plug. So if you put the plug in, yes, uptake continues and water accumulates, but it's not because insulin is sending more fat in. So that's part of it. So if you have more circulating insulin, it's going to be, you're going to, the water level is more likely to rise. However, the problem that I have with people using medications that mess with insulin levels as support for the carbohydrate insulin model is that, well, twofold. One is that they have other effects that you're not talking about. So like GLP-1 agonists, right? GLP-1 is a super important increase in which, again, feeds into the satiety system. And if we're talking about refined carbohydrates, those start to bypass that system, which is why you get less satiety, which is why you get overeating. So that's super important. And then the other thing is they're predicated on the idea that the reason why those drugs exist is they're predicated on the idea that insulin is there to shove glucose into cells, which is not true. So using those drugs that are acting in different ways in different areas doesn't support necessarily the idea that insulin released from the pancreas in a normal postprandial, sort of phase, sort of like a rise and then a decrease, that they're going to have the same effect because I don't think they do. However, like based on what we know about insulin, yes, having more circulating is going to decrease the likelihood that fat is released. But what you would know from like looking at endocrinology is that the level of the hormone tells you nothing about the signal of that hormone, right? So having a certain amount of testosterone or growth hormone or insulin circulating tells you nothing about what's actually happening in the cell in response to that. So like all of this just means that it's much, right? So like the basic idea that yes, the insulin stops fat being released in adipose tissue, that is absolutely true. Like I don't think anybody would be able to argue with that. But like all these other things mean that it's going to be much more difficult to look at that. And then when you look at people going on low fat, high carbohydrate, calorie restricted diets, compared to the same number of calories, those guys will have higher levels of insulin, but they'll lose just as much weight. So, and then again, that's, how much signaling are you getting for a certain amount of insulin is going to be very different. So just measuring the amount of insulin doesn't tell you anything about the signal itself. So like, it wasn't really a coherent answer, but that's why all the reasons why I think that these arguments start to happen.
You mentioned in the beginning of this podcast a euglycemic clamp, a hyperinsulinemic euglycemic clamp. And one of the most magnificent studies I've seen done was from Dr. Sinha in the Yale system where I trained. And what she did was she put people onto a hyperinsulinemic euglycemic clamp, actually a euglycemic hypoglycemic clamp, but it was a modest hypoglycemia. It was like from 100 sugar, if your sugar level was 100 down to 80, very, very modest, right? Well, first she gave a ton of insulin and measured what happens in the brain in terms of the food addiction areas of the brain, okay? And she found nothing with a ton of insulin, stable blood sugar. There was nothing there, whether you were thin or obese, nothing happened. Then she just dropped the blood sugar 20 points. 20 points, right? Insulin release doesn't happen in a vacuum, right? There's a physiologic effect. So ton of insulin drops the blood sugar 20 points, and now the addiction areas of the brain are lighting up. So I wonder, if we should change the carbohydrate insulin model to actually be the carbohydrate insulin glycemic model of obesity. Because time and time again, we've seen that if, for example, with Atkins, the more your glycemic variability is improved, the decrease in appetite and the decrease in intake. So I wonder if the true effect is glycemic variability secondary to insulin mitigating appetite. What do you think?
Yeah, I think that's absolutely important. So like the size of those deltas, right, the changes in your blood sugar are going to, they're much more important for cardiovascular health and, cognitive function, like much more than say just your average blood sugar, right? And I think that, again, I would always argue that it should come back to quality, right? Because the quality of the carbohydrate determines the size of the blood sugar spike. It determines the size of the insulin release, and it also determines the calorie density of the food, which also plays into satiety signaling. So above and below 1.5 calories per gram of food, roughly, is where you can and can't regulate satiety, relative to your caloric requirements. So, yes, I think that the issue that I have is that when you talk about carbohydrate or glucose and insulin, is that you immediately put those things forefront when there's lots of other things happening at the same time, which I think are potentially more important, and also make it easier for us to just regulate this ourselves rather than worry about absolute glucose and insulin levels. So yes, absolutely important. I think that's a bigger effect, right? The glycemic variability, absolute spikes in glucose, how much it then drops afterwards, the speed of the drop, all of that really does affect, our satiety and our hunger signaling. But there's other factors at play as well.
Sorry, Kristen. Kristen's like, oh my God, when will we stop talking?
No, I'm just absorbing all this.
We gotta hit him with the smart questions.
Yeah, no, you're doing a great job, Tro. I think it's important to highlight too. I know with our medical weight loss patients, and I'm sure with yours too, Tro, one of the first things we try to teach them is to get rid of the processed food because of its effect on the satiety hormones that can travel up to the hypothalamus and tell you to stop eating. And it's amazing how many keto treats and low carb treats there are now. These keto brownies and keto cakes. I mean, you can make anything low carb, but so much is still processed food. And I think a lot of patients do get into trouble when that's the main part of their diet. Special occasion, birthday, celebrations, fine. I think it was really important to highlight that different types of carbs, particularly the refined carbohydrates, really do mess with the satiety signals. And that's key for weight loss. Nothing derails a diet faster than being hungry all the time. There is so much I wanted to go over here, and I know we're at about the hour mark. I wanted to ask you about ApoE4, just being the brain scientist that you are here, an expert with brain development throughout the lifespan. There's been some controversy with ApoE4 and saturated fat metabolism. Is a ketogenic diet beneficial for prevention of Alzheimer's, or are people with this allele going to be putting themselves at risk with all the saturated fat? Real quickly, can you just give us a couple highlights? I'm sure you could talk about this for a long time.
Can I talk about it quickly? Maybe not, but I guess I can try. It's worth so I guess just to quickly say that ApoE4 carry it, so your apolipoprotein E SNP or genotype, 4 being one of them, and it's probably the strongest or most significant genetic contributor to your risk of Alzheimer's disease, outside of much more significant genetic mutations like in the senilin genes. Your ApoE status contributes about 5% of your Alzheimer's disease risk. It's much greater than almost any other genetic risk for any other disease that happens commonly. And yes, having an ApoE4 copy, either one or two, does affect the way that you handle saturated fats. So you do seem to see greater increases in LDL cholesterol in response to saturated fats if you are an ApoE4 carrier. It's worth saying that your ApoE4 status is not a dementia sentence. Most people who get Alzheimer's disease or who get age-related cognitive decline or age-related dementias do not have ApoE4, and there are people who have ApoE4 who don't get those. I am separating those things out. So Alzheimer's disease, the way it was originally described, is almost certainly associated with single mutations in genes that cause early onset Alzheimer's disease, like in senilin genes. That's very different from what happens in most people, which is just an age-related cognitive decline or dementia, which is where you might see ApoE4, again, dramatically increasing risk. In some scenarios, ApoE4 may be protective for cognitive function. So they've looked at the Bolivian Tsimane, which are a hunter-gatherer tribe, where they've done lots of studies of their disease risk and some of their genetics and their diet and all this kind of stuff. And in those guys, if they have a high parasite burden or an eosinophilia, so they have high levels of eosinophils in their blood, those guys who have ApoE4, which is part of the immune response, it's part of an inflammatory response. If you have ApoE4 in that setting, it's actually protective of your cognitive function. So it's very much the contribution of ApoE4 to dementia risk is very much environmentally dependent, and it's because of all these environmental mismatches that we're exposed to that have so it's an interaction, right? It's not just having it. Now, when they've looked at people who have dementia, there is it seems to be that all types, but ApoE4s included, can get some benefit from having ketones circulating, and that's because they become there's two parts. Ketones become precursors to things like cholesterol and other things that you might use to repair your brain if it's injured, and then they're also used as a metabolite, right? That's what most people think about. And in the insulin resistant brain, and certainly there seems to be insulin resistance in the brain in most people who have age-related cognitive decline or dementia, then ketones kind of bypass that, and they provide metabolic fuel that means that your brain can keep running even though it's not processing carbohydrates well. So those do seem to benefit those with ApoE4, but they may need higher levels of ketones relative to people who don't have ApoE4. The interesting thing then becomes, how do you get those ketones higher? And again, I have no great randomized control trial. These just haven't been done yet. But thinking about the work of people like Dale Bredesen, who are watching this stuff happen in real time, they will recommend actually that ApoE4s, because of the cholesterol effect, but also potentially because of the ketone effect, they'll recommend that those guys have more monounsaturated fats than saturated fat in the diet. And there's two parts of that. We already talked about fats in the diet. If they're more unsaturated, you will have higher circulating ketone levels. So if you're ApoE4 and you need higher ketone levels to get benefits in the brain, then that's going to be beneficial. Then the other side of that is you'll get less of an increase in LDL cholesterol. Now, and so from a heart disease standpoint. So again, LDL cholesterol and heart disease is super complicated. However, if you are somebody with established metabolic disease, which is almost certainly going to be the case in somebody who has dementia to some degree in some part of the body, then even if you dramatically reduce your carbohydrate intake and you dramatically reduce your insulin load, I don't think LDL cholesterol gets a free pass in terms of coronary artery disease risk. There's still you have some established disease, and then just saying that you went keto isn't going to suddenly get that to disappear, right? So I think that it is worth mentioning in people who have established disease that these things may be important, and maybe it's better to get most of your fats from, say, a nice high quality olive oil than from butter, right? I think that's going to potentially be important and maybe more important in ApoE4s for all those reasons.
I'm going to ask you a quick question. Let's make it really simple. What do you eat? What's a typical day's worth of eating look like? Or two, give me a couple. What does Dr. Ragnar eat?
Yeah, so usually breakfast for me is usually some kind of leftovers. So it'll be a good chunk of meat and some vegetables. So I usually have a fairly low carb breakfast. In the middle of the day, I'll often have some Icelandic yogurt we call skyr, which is basically a very, very high protein yogurt, probably with some fruit, maybe some berries. And then in the evenings,
Wait,
again,
full fat or skim?
Oh, it's traditionally Icelandic skyr is skimmed. That's just the way it comes.
Got it. Okay.
And then in the evening, again, I'll have a big chunk of meat or fish, some vegetables. Maybe there'll be some carbohydrates, maybe a bit of rice, a bit of sweet potato. Compared to the American standard guidelines, I am definitely low carb, but I'm not keto.
I mean, it sounds like you're having. I bet you make ketones if you exercise.
Oh yeah, yeah.
Yeah, it sounds like about 60 to 100 grams of carbs.
Yeah, something like that on average. I mean, maybe some days it could easily be 200, but I'll average 100 or less, and probably 250 at least grams of protein.
Yeah, it sounds pretty high. And no intermittent fasting?
I have about 8 to 9 hour eating window every day.
Oh, okay. You said breakfast, lunch, and dinner. I was like, damn.
Okay, yeah. So breakfast is the 9 to 10 a.m. Lunch is maybe at 12, and then I'll work out in the afternoon. Then dinner's at 6.
Got it. Okay, the afternoon workout. I love it. I do the same thing.
Yeah.
Awesome. How do people get in touch with you? How do they find you? How do they ask you questions? Probably we're going to get, hopefully we can get people to, how do they support you? How do they find you? How do they get you?
So the easiest way to find me is probably on Instagram. I'm at Dr. Tommy Wood on Instagram, and I'm at Dr. Ragnar on Twitter. I don't do much on Twitter, but I'm stealthy on Twitter. I watch the happenings, but I don't usually dive in because life's too short. And then drragnar.com is my website, which hasn't been updated for a while, but they can find me on there. There's like if you send me a message through the website, it will end up in my email and I'll try to respond. So DM, if you want to ask me a question, DM me on Instagram. That's probably where you get the fastest response. Or you can go through my website as well.
Well, thank you so much for coming on. This was a great conversation. You're a wealth of information, and hopefully we can get you back on in the future, because I still have a list of things I want to pick your brain on. You're very knowledgeable in the area of metabolic health, and maybe next time we can dive further into athletic performance. I know that's a big topic for you, and you're quite experienced with that. So Tro, any last words?
No, this was awesome. It's clearly, it's great to, I think people try to typify low carb proponents as, people who, say that you shouldn't eat fruit and believe that insulin is evil and that, carbs are the only thing that can make you fat. It's as if that's the only, those are the 3 talking points. And it's great to hear somebody who's, evidence-based, knows the literature, and has a very pragmatic, science-based approach. So thank you for everything that you're doing. Thank you for being who you are, the research that you're doing, the help that you do with coaching, and thank you for everything.
Yeah, thank you so much. It was great to finally get to talk with you guys.
Great. Thank you so much, and we'll talk to you guys next time.